Sure. So when you eat fat or your body pulls fat from your stores, those long fatty acid chains are broken down in a process called beta-oxidation.
Beta-oxidation.
Think of it like a chemical disassembly line that just chops up those long chains into little two-carbon pieces.
And what do we call that two-carbon piece? The end product of chopping up the fat?
That end product is always acetyl-CoA. Now, acetyl-CoA is fantastic stuff. It's the main molecule that goes into the Krebs cycle to generate tons of energy, of ATP. It's where ketones come to.
Okay, that sounds great. If it's the energy source, why can't we just, reverse it and build it back up into glucose?
Because here's the catch, and this is the fundamental, irreversible limitation in humans. Once you form acetyl-CoA, the chemical reactions in our bodies just don't allow it to go backward to form the 3 and 4 carbon molecules you need for gluconeogenesis.
So it's a one-way street.
It's a perfect analogy. It is a one-way street with a biological toll gate you can't get back through. You can go from the precursors to acetyl-CoA, but you cannot go the other way.
And what are those precursors? The two absolutely essential ones that acetyl-CoA just can't become.
The two molecules we absolutely need to kickstart the whole glucose-making process are pyruvate, which is a 3-carbon molecule, and oxaloacetate, a 4-carbon one. You have to have those to run the pathway.
So, just so I'm getting this straight, my body can break down fat into 1,000 acetyl-CoA molecules, which is great for general energy.
Mm-hmm.
But not a single one of those can be turned into pyruvate or oxaloacetate, which means they're totally useless for making new blood sugar.
That's it, precisely. It's a hard limit. It means the vast majority of fat in your diet, those long, even-chain fatty acids, cannot be used to make glucose. This biological fact forces the body to look somewhere else, even if you're eating butter all day long.
It's fascinating. It's like the body is saying, I need a key with this very specific shape. That's the pyruvate or oxaloacetate.
Yeah.
And fat only gives me a key with a different shape, the acetyl-CoA.
It just doesn't
Yeah.
fit the lock. It doesn't. And it shows that just having a lot of something, metabolic abundance doesn't mean you have metabolic flexibility in every direction. The pathways are very specific.
Okay, so we've established the blockade. Fat is out.
Mm.
Which brings us to that third pillar of keto,
Yeah.
protein. What does all this mean for that moderate to high protein component? If fat can't provide the carbons, where do the building blocks for that de novo synthesis actually come from?
And this is where the protein-rich component of your diet becomes, well, an absolutely indispensable metabolic lifeline. In a carb-starved state, the body turns to protein, specifically the amino acids from that protein, to fill that gap.
So the liver is literally taking apart protein to build the sugar it needs for the brain. How does that work specifically?
It's a highly efficient system. The liver uses any excess amino acids, any that aren't immediately needed for building muscle or making enzymes. And crucially, it doesn't just use any old amino acid. It specifically targets the glucogenic amino acids.
Let's pause on that term glucogenic. That sounds key. Can you break that down for us?
Absolutely. So amino acids generally fall into 3 buckets: purely ketogenic, purely glucogenic, or a bit of both.
Okay.
Ketogenic ones, like leucine and lysine, they break down directly into acetyl-CoA. So they just produce ketones, they hit that same metabolic blockade as fat.
So they become fuel, but not the specific sugar fuel the red blood cells have to have.
Correct. But the glucogenic amino acids, think alanine, glycine, serine, their carbon skeletons can be broken down directly into either pyruvate or oxaloacetate.
Our 2 essential precursors.
The very same. Alanine, for example, can be converted into pyruvate with very little effort. It's a straight shot right into the gluconeogenesis pathway.
So the protein in your diet is providing the exact shape key the liver needs to get around that metabolic roadblock and make glucose.
That is the whole story.